Okay, so we're going to start talking about areas of circles and areas of sectors. So a sector is kind of like a slice of pie. It's a cutout portion of the circle. Okay, so we're going to look at some vocabulary. Our population density. It's used a lot in cities and counties and states. And we're going through a big census right now. We're going to look at population densities to redistribute representatives in the House. So it is something that we use a lot. Our population density of a city, country, or state is the measure of how many people live within a given area. So sometimes it's blocks, sometimes it's miles, but that unit of measurement is usually given to you. A sector of a circle is a region bounded by two radii of a circle and their intercepted arc. So it's like a slice of that circle, a slice of the pie. Okay. Previous vocabulary that we're going to use also is our circle, of course, a radius and our diameter, and the intercepted arc. Our intercepted arc is where those portions of the radiuses create that slice in the sector for us. All right, so area of a circle is pi times the radius squared. Should be familiar with it. We're going to find the area of a circle with a radius of 2.5 centimeters. So using our formula, we're going to plug in that 2.5 for the radius, square it, and we get our answer in terms of pi. So 2.5 squared, and if you know your squares, 25 squared is 625. We have two decimals, so it's 6.25. Little mental math for you. Our answer in terms of pi's would be 6.25 pi, or if it asks for a rounded answer in your textbook, then you would multiply 3.14 to get 19.63 centimeters squared. Now we are talking about area now, so all of our measurements are going to be squared units. All right, now what if we want to find the diameter of a circle with an area of 113.1 square centimeters? So we have our formula and we plug in what we know. We know the area of the circle this time. So our egg is going to change to 113.1. And we want to solve for the r because that's the only thing that we don't know right now. So we divide by pi. And then to undo the square, we take the square root. Type this in your calculator, the square root of 113.1 divided by pi, and we get approximately 6. Now remember, that's our radius in our formula. Our question is asking for the diameter. So how do we find the diameter if we know the radius? Well, we just multiply it by 2. Oh, that's our answer in terms of pi. Multiply by 2 to get our diameter, and we get, which is 12 centimeters. All right, now what if we want to know the population density? It is the number of people divided by the area of the land. It's usually given in terms of square miles, but can also be expressed in terms of blocks, city blocks, like sometimes in New York City, they'd use those measurements. About 430,000 people live within a 5-mile radius of the city's town hall. So we want to find the population density of people per square mile. So we're going to take the number of people and divide by the area of the land. Okay. So our number of people is the 430,000 people. The area of our land, it says a 5-mile radius. So we're taking the area of a circle with a radius of 5. So our pi times radius squared is our area of the circle. So 5 squared is 25. 430,000 divided by 25 is 17,200. Divide by pi. There's our answer in terms of pi. Divide by pi, and we get approximately 5,475 people per square mile. It's a lot of people in 1 mile. All right, a region with a 3-mile radius has a population density of about 6,195 people per square mile. I'm going to find the number of people that live in the region. So we're talking about the full region now. So thinking about what we know the population density is 6,195. The number of people is what we're trying to find. So this will be our x. And the area of the land, we know there's a 3-mile radius. So we use the area of a circle to help us down there. So pi times the radius squared is our area of the circle. Let's square this. We get 9 pi. We want to get rid of the fraction, so we multiply by 9 pi on both sides of our equation to get this 9 pi times 6,195 equals n, or x. And then we multiply everything, and we get approximately 175,159 people in that region. Right, the sector of a circle is a region bounded by 2 radii. So our radii here is the PA and PB. And it's bounded by the 2 radii and the intercepted arc. Our intercepted arc is AB. So this little slice of the circle is our sector. The area of the sector, the ratio of the area of a sector of a circle to the area of the whole circle is equal to the ratio of the measure of the intercepted arc to 360. So the sector of a circle, that's our area of the circle, is a ratio to the measure of our whole circle, the area of our whole circle. So here's our area of the sector divided by this whole circle. So ratio means divide. Okay, is equal to the ratio of the measure of the intercepted arc. So the measure of our arc divided by 360, the full circle. So we're setting up a proportion here. Or if we solve for this proportion, we get that the area of the sector is equal to the measure of the arc times the area of the circle divided by 360, which is this full proportion times the area of a circle. So to find the area of this, we're going to find the areas of the sectors formed by angle UTV. So step 1, we want to find the measures of the minor and major arcs. We know that in angle, the central angle, so we know the arc, the measure of the arc UV is 70 degrees. And then we know if this is 70 degrees, the major arc is 360 minus 70, which is 290 degrees. Step 2, we're going to find the areas of the small and large sectors. So the sector area is equal to pi r squared times the measure of the arc divided by 360. Our small sector is pi times the radius is 8 squared. The measure of our arc is 70 degrees divided by 360. So if we square the 8 and we reduced our fraction divided by 10 on top and bottom, we get this answer. And we can multiply 64 times 7 over 36 to get 12.4 pi. So here's our answer in terms of pi. We multiply times pi and we get 39.10 inches squared for the small sector. For our large sector, we can use the same formula. We have the same radius as 8, but the measure of our large sector is 290 degrees. So we square the 8 and we reduce our fraction, divided by 10 on the top and the bottom. Multiply the 64 and 29 over 36 to get about 51.6 pi. Then multiply times pi, and we get 161.97 inches squared. Now let's find this area of sector FDE. So this sector here in the orange color. So here's our formula. We know the radius is 14. The measure of our arc is the same as our central angle, so the measure of the arc is 120. We square the 14. If you memorized your squares, that's 196. Reduce the fraction and we get 1/3. 196 times 1/3, or 196 divided by 3, gives us 65.3 pi. That's our answer in terms of pi. And then we multiply times pi to get our rounded answer, 205.25 feet squared. Now find the area of circle B. Okay, we know the area of the sector. And we know the central angle. So if we use our formula, we plug in what we know. The area of the sector was 35. The measure of our arc is the same as our central angle, which is 40. Okay, so we plugged in those things that we know. Now the area of circle V is pi r squared. So we're solving for pi r squared. So let's reduce our fraction. They're both divisible by 40 on top and bottom, and we get 1/9. To get rid of this fraction, we can multiply by the reciprocal, which would be 9. So we're multiplying by 9. 35 times 9 is 315. Pi r squared is the area. So 315 meters squared is our area of circle V. A rectangular wall has an entrance cut into it. You want to paint the wall. We want to find the nearest square foot. What is the area of the region to be painted? And this helps us because we know approximately how much area can be painted in a gallon of paint versus a 5-gallon tub versus a quart. And you don't want to buy too much paint or too little paint. So knowing the area of the surface you're painting is helpful. All right, so let's start with our wall. We know the dimensions of the wall is 36. And if we add these together, we get 26, right? So 36 by 26 is our square wall or rectangular wall. So the area of the wall is 936 feet. We multiply those two dimensions, 36 times 26. And then our archway is the area that we're not painting, right? So our archway, we have a rectangle here, or a square, because that's 16 and that's 16. So we have a square and we have a semicircle. So we need to take those areas out since they are cut out. So the area of the square is 16 times 16, which is 256. Now the area of our semicircle is half of a circle, half of the area of the circle. So 1/2 of the radius. This is the diameter, so our radius would be 8 squared pi. So this is the area of the circle. 8 squared is 64. half of 64 is 32. Oh no, you can reduce that to 32 pi. Okay, so we can plug this into our calculator. The full area, 936, minus the area we cut out, 256, plus, and yes, this has to be in parentheses, or you subtract them both, minus the 32 pi, and we get our answer. Okay, so the area of the wall sorry, that was out of order. So the area of our wall was given. Okay, the area of this figure. We want to look and see what kind of shapes there are. Okay, so we see a semicircle and we see a triangle, and we know it's a right triangle. So we need to find the area of a right triangle and a semicircle. So a semicircle is half the area of the circle. Our radius is half of 7, so 3.5 is our radius. We square the 3.5 and we get 12.25. And we multiply times 1/2 to get 6.125 pi. So that's the area of our semicircle, but we need to add also the area of the right triangle. So the area of our right triangle is 1/2 base times height. Our base is 7. Our height is 7. And we multiply all that together to get 24.5. Now we need to add the area of our semicircle with the area of our triangle to get our total answer here. All right, guys. In Big Ideas, you have an assignment set up for 11.2. Good luck, and let me know if you have any questions.